2010, he held several leadership position in industry, telecom industry mainly, in US and Canada. He also deposited several patents related to fiber optical and quality of service. So his talk will mainly focus on standardization process, but also challenges related to 5G network mainly, and technology related to 5G, so IA, machine learning, IoT, and smart cities. And okay, Bilal, it's you.
Thank you very much, Dr. Ahmed, and good morning. I'll use this one. Thank you. Good morning. It's a pleasure to be here with you today, and thank you to Dr. Tariq for having invited me to join you at this conference. Today, as you mentioned, I'm based in Geneva, but Geneva is more or less shut down today because of the Holiness Pope visit to Geneva. So the Pope is in Geneva, where we're having the conference in Rome. That's a nice arrangement because all the police, traffic control, and so on, with the Pope being in Geneva. Today, I'd like to maybe share with you three things in the talk. The first one is to just get an overview of the business environment around ICT and society, the various moving parts that are happening, the digital revolution or the fourth industrial revolution. Then the second point is what the ITU is doing to address a number of these transformations. And the third part, how academia, university, research institutes can and are taking part in the work of the ITU. So in terms of looking at the business environment, is this the clicker or? No, it's just use the okay. Just the pointer. Okay, thank you. So if we look at the business environment today, some of the key transformational elements are, as Dr. Mohsen mentioned, the Internet of Things, the small devices, the cost effectiveness of those devices, and the mapping of those devices on the physical world. So Dr. Mohsen talked about the implantable devices. So we're mapping devices onto the human body, but in the context of a smart city, we're mapping the sensors into the city. So now we have two views of the world. We have the virtual or cyber view, and we have the physical view. And this mapping of Internet of Things devices is opening up a whole new set of opportunities and paradigms in how to manage, share, and collect the data. Eventually, it's all about the data that we collect and analyze. So as we move around the circle, we have a lot of data about people in terms of social media and information through the mobile application. That data now is opening up for opportunities to treat it, to do analytics on it. So we talk about machine learning, we talk about artificial intelligence. This data is, of course, stored in the cloud. And as we move into 5G, I'll show in a few slides how edge computing is an important element of providing the 5G promise. As new security mechanisms, we are looking at blockchain, either in the financial sector or in other sectors of transactional sectors. So these elements are really shaping the digital transformation and driving a number of investments, number of new technologies, and also driving new regulations in various countries. So let's take a look at them and perhaps the economic impact of these according to the World Economic Forum. The impact of the key industry of the digital transformation until 2025, as you can see, has a huge impact on the consumer industries, from the value to the consumer industry and the value to the society. If we look at on the next slide, the value at stake for the industry, the consumers, and the wider society, there are two lines. One is the value to the industry, the other to the society. We see that in this digital transformation, the network still plays a critical role and probably has the lion's share in terms of the transformation. But the other aspect is what's beyond the pipe, beyond the network. So the applications, the data processing and management, the artificial intelligence is where a lot of the new investment and opportunities is taking place. If we look at the verticals, so ICT initially was about computing and about its own field, But now with this mapping of ICT onto the physical world, we have a lot of intersection with the verticals. So we have intersection with the media. Now it's a lot of social media, a lot of content distribution over the network. There is an intersection with the electricity, both from renewable energies, but also from smart metering and more efficient use of electricity, using it in electrical vehicles and so on. The intersection of ICT with logistics, shipment, smart contracts, container tracking, and so on and so forth. The other huge impact to the society is in the automotive sector, because one of the sustainable development goals is to reduce the number of deaths due to automotive accidents. And perhaps the only technique or tool in the toolbox available is the intelligent transportation system, having the vehicle having a lot more sensors and intelligence to prevent the accidents. And that's why you see in the automotive sector, the impact to society is quite significant, perhaps not as much to the automotive industry that has to invest more into bringing ICT in the car, but the impact to the society is quite large. And then in terms of e-commerce, also there is a lot of opening through e-commerce trading, the availability of digital currencies. So these are shaping a lot of the discussions around standards, regulations, and how the industry is reacting to it. If we look at sort of a validation of this view, in January of this year at the Consumer Electronics Show, one of the biggest shows perhaps in the US in Las Vegas, at the end of the show, there were about 5 areas that were retained as the key trends in 2018. Artificial intelligence, 5G, self-driving technology, smart homes and smart cities, sports technology, AR, VR, health, fitness, and wellness. So in the ITU, we use this as a way to validate and see how our work that is mainly driven by the member states, the private sector, and the academia is mapping to the industry trends. And what I will be sharing with you on the next point, the second point of my presentation, is some of the work in the ITU on that. So first of all, what is the ITU? It's the International Telecommunications Union. It's a United Nations specialized agency for information and communication technologies. Who knows how long the ITU has been around? How long?
50 years.
153 years.
Wow.
The ITU actually predates the United Nations. The reason the ITU was created in 1865, on May 17, was to create a standard around telegraph. It was used to be called the International Telegraph Union. And before the ITU existed, the telegraphs used to be sent within one country, printed on the border, carried by hand to the next agent, and typed again. And so there needed to be an international standard to really send the telegraph. So at the time, they needed a data format, a data plane, they needed a signaling plane, and they needed an accounting and charging plane so that the money flows between when you pay for your telegraph and all the intermediaries get their piece of the pie. And ITU has been the most enduring organization in the international system because as the technologies evolved, ITU evolved with it. So after the telegraph, we had the telephone, the fixed lines, and then we had the wireless technology, then we had the fiber optic technology, the internet, the mobile technology, and so on. Now we talk about data and artificial intelligence, machine learning. And so the membership of ITU renews itself. When we talk about the ITU, I'm not talking about the staff working for the ITU. It's really the whole world community, which is the 193 member states, about 550 big companies. We call them sector members, private sector. So companies that you know in the field like Huawei and Orange, France Telecom, so operators, vendors, and now more and more parallel vectors or verticals. Lately, we had companies like Hyundai join ITU, the car manufacturer from Korea. Why? Because of the intelligent transportation system, because the car is becoming an ICT device. The car has a communication gateway. The car needs a map, an up-to-date map. If we talk about autonomous driving, the car cannot drive autonomously without having an up-to-date map. And that map needs to be updated in real time. And if we have security threats and the map is tampered with, you can have accidents. So we needed to have an over-the-air software updates that are secure. And that's when Hyundai joined ITU to bring its protocol as a contribution. It was adopted as an international protocol standard so that all car manufacturers today can have a reference, an international reference for that. We have insurance companies joining because of the medical devices and the certification of medical devices. And we have about 140 academia and research institutes that are very actively involved in developing the standard, in networking. I'll talk more about, that's my third point later on, about how academia has an important role to play in the ITU system. So in a nutshell, three things that the ITU does. The radio sector does the allocation of frequencies and satellite orbits, and we happen to be very close to the European Space Agency. So last night when we met the CTO of the agency, we talked, and he, of course, the interference of frequencies to the satellites, also the determining the orbits around the world happens, and the filing takes place in the radio sector of the ITU. In the standardization sector where I work, we develop the international standards, including the X509, the PKI system, which is an old security scheme that is now becoming threatened with quantum computing. But at the same time, we have a Canadian company that is leading the work on quantum cryptography that is bringing a new standard on this topic. And then the third element is we have a development sector that looks at helping developing countries get up to speed on regulation, new technology, to ensure that they can adopt and use the latest ICTs. So let's start with 5G. 5G in the standards in the ITU, we call it the IMT family. The IMT standing for International Mobile Telecommunications. So IMT, 3G and 4G mobile broadband systems are based on the IMT standards. The ITU established the detailed specification for IMT 2000, and the first 3G deployment commenced around year 2000. After that, they instead of using a number for a year, they just call it IMT Advanced because the year of deployment wasn't really clear, but that's the 4G system. And today we talk about IMT 2020, and it happens that the timing will be 2020 when the standard will be finally ratified. The 3GPP plays an important role in this, but the final standard that is referred to and adopted by the world is an ITU standard. And the way it works is that the ITU establishes the requirements for 4G or 5G. Then the industry goes and works on solutions and proposals. The proposals are evaluated against those requirements, and then one of those proposals will emerge as the standard. And now I'll show you in terms of where we are with the 5G standard in a moment. But one key aspect of 5G, it's not just about more bandwidth. As we went from 3G to 4G, it was just more about more broadband. Moving to 5G has two components at the bottom, the massive machine type communication and the ultra reliable and low latency communication. And those two additional elements are bringing new requirements on the architecture of the network, the design of the network, and the techniques that are used within the network. So in terms of the timeline, where are we with the 5G standard? In the 2012 to 2017 was the preamble, the preparation of those requirements, the agreement of the vision. The triangle that has those three elements is actually documented in an ITUT report as the vision for 5G. So setting the stage for the industry to prepare its proposals for 5G standards. Now in the 2018 to 2020, what's in yellow has been completed, so we have proposals. We're in the process of evaluating proposals and to build consensus. At the end, we need to converge on a single standard. There is the conference preparatory meeting report that will be for WRC, the World Radio Conference 2019. It will be next year in Sharm el-Sheikh in Egypt for about 3 weeks' time. And that's where the frequency will be agreed, and it's a treaty. The conference is a treaty where every member state signs the treaty at the end of the conference, because they need to observe the frequencies that have been allocated, the power that is used within those frequencies to avoid interference across borders. And that's why the ITU plays a critical role for a critical resource like frequency when we talk about mobile networks. And then in 2019, 2020 will be the detailed IMT radio specification. And at that time, we can talk about standards-based 5G IMT deployment. At the moment, we see a lot of trials, which is a very good sign. We have seen trials in Korea during the Olympics. We are seeing other trials in Japan and Brazil and other places. And that's good to validate some of this technology and see if we are ready, the industry is ready for IMT 2020 or 5G deployment. But there is something that's important to know, that 5G is not just about radio. As I mentioned in the triangle with the three diverse requirements, broadband, massive connectivity, low latency, requires a different architecture and requires the convergence of mobile and fixed networks from a control and management perspective. And that's when one element of machine learning comes in, because the 5G network becomes quite complex to manage in real time. You have to adapt to beamforming antennas. You have to do slicing of the network. Some of these decisions have to happen in real time. And machine learning becomes a very effective tool to be able to have algorithms run in real time and take those decisions for establishing slices, doing prediction of where the user is going to be based on a number of data sets, and pointing the antennas towards a crowd, for example. These are some of the examples of that show that there is a lot of conversions happening between the mobile and the fixed aspects. When we talk about low latency, 1 millisecond delay, it's not going to be possible without having edge cloud computing. It's not going to be possible without having fiber to the micro station. So that shows a convergence between fixed and mobile. So it's an important element to keep in mind as we talk about 5G. It's not just about wireless. It's not just about radio. But a lot of the innovation is actually happening in the fixed network, in the architecture of the network, and the use of new techniques like machine learning for that. So what's beyond the radio interface, a number of standards that were published by the ITUT are the softwareization, the slicing, and the fixed mobile conversions. When we say standards published by the ITU, they're publicly available documents in PDF that anyone can download. Most of the technical documents are in English, but when we have standards that have a regulatory implication, we translate them into the 6 languages of the UN, which are Arabic, Chinese, Russian, English, Spanish, and French. And that is important for the world population to be able to quickly adopt and adapt to these new standards. We also have a standard on the network management and orchestration. For operators to move into 5G, today they have a big problem with operating and managing 2 separate networks, the fixed network and the mobile network. And that's a very costly proposition. One of the promises of 5G is that you have a converged fixed mobile network, which would benefit from having a common management and orchestration function. And when we talk about the programmability of the network, you really need to have those elements in place. And that's why we have a standard on the network management and orchestration. We also have a lot of work on using fiber optics front haul connectivity to provide the required bandwidth at the right place. So if we're talking about programming and slicing, you need to have a lot of flexibility in the fiber optic at the layer 1, layer 2 level to be programmable. And in that respect, we have a study group 15 that has been working for a long time on SONET SDH, passive optical networks, DSL, G.fast, which is putting a gigabit on copper. All of these connectivity standards are now being looked at from a 5G perspective. And finally, we have a focus group that's open to members and non-members of the ITU that's looking at the 5G machine learning. The chairman is actually from Fraunhofer Institute. So here's an example of a research and academic institute that is a member of the ITU that takes a very active role in defining the future standards. But more importantly, they bring their innovation and their patents that they're filing in Fraunhofer to become standards essential patent. And the most valuable patents are the standards essential patents. Companies like Qualcomm, for example, generate $4 billion or more US dollars per year because they have essential patents in the wireless communication. And so many other companies do the same. They have royalties that they generate. So Fraunhofer, for instance, has been a very active standard setter in H.264 and H.265 on video coding. And there is a patent pool in those standards, and any company or research institute that has patents that become part of the standard will have a royalty back from the patent pool, which could generate revenues for future research. So this is a very interesting model to consider for research organizations and universities in joining the standard setting organization in the ITU, for example. Other aspects that are new in the context of 5G include new networking technologies, so data-aware networking or information-centric networking. This is really going beyond TCP/IP. This is looking at packet transport in a different view. Huawei brought to us a contribution a couple months ago on Network 2030, where they really want to go beyond completely draw a new IP. They call it new IP. I asked them, please don't use the word new IP because I don't want to have any fights with the ITF, but call it a new networking layer. And so it's a multi-dimensional proposal, and it will be probably discussed next week in Geneva at our study group 13, looking at future networks. What else do we have in the 5G? So just to summarize the 5G wireline, there is the ICN, information-centric networking, the softwareization, which is really programming the network. Instead of having a physical pipe, you need a slice end-to-end from your device or from your end user application or server through the edge of the network, through the core of the network, all the way to the other end. And that slice could be dynamically adapted and created and changed depending on the application, the quality of service you want, the bandwidth you want, the security mechanism. And that's a really new paradigm in the context of 5G. Slicing, front haul and back haul connectivity. SDN, virtualization and cloud have been around before 5G came along, but are becoming an important and essential tool in delivering the promise of 5G. Maybe in the interest of time, I'll skip on this. But also the other message that's important is that we're moving from a hardware world in networking to a software world. Moving from dedicated appliances and dedicated wires and radios to virtualized functions, virtualized links, on generic servers, sharing storage, compute facility. So the title of this conference is Networking and Computing, and really we're now at the very important cross point of convergence of compute and telecom. We've been talking about it in the past, but now it's happening. When you look at the 5G network, it's an absolute convergence of compute and networking. You have a lot of servers running software to run the network, to control the network, to open the slices, to provision the links in dynamic fashion. You have a lot of data stores to enable the machine learning. So that, for me, it's a very clear convergence between compute and telecom. Let's see. So in summary, for 5G and IMT 2020, it's developed in collaboration with the ITU membership, so the member states, the private sector, which includes both vendors and operators, as well as academia and research institutes. And it's based on a consensus-driven model. We don't vote in the ITU like they do in the IEEE, for example. Each model has its pros and cons, but voting is avoided in the ITU because at the end you want the whole world to convene or agree on a topic or a standard that they would deploy, and there is no winners or losers. It takes a little bit more time, but at the end you have at least a consensus that is adopted worldwide. The outcome of the evaluation and assessment of the proposals will be in October 2019, so next year. All these proposals for a 5G spec. This week, 3GPP input their proposal on the specification from IMT to the ITUR. We will have a dedicated specification of IMT 2020 in year 2000. Beyond that, ITU will continue in the development of enhancing IMT globally. Two other elements at the end is that 5G is more than new radio interface. and 5G leverages the convergence of compute and telecom industries. So it's a true opportunity in that sense. Yesterday, I was in the morning at the European Parliament. I was invited to do a briefing to a number of parliamentaries at the EU because they're preparing the European digital code, and part of the digital code is the EMF, electromagnetic frequency limits. And in the context of 5G, EMF could be, the limits could be very limiting to the deployment of 5G. Some of the slides I shared yesterday at the EU Parliament were around the history of the work of ITU on electromagnetic frequency dates back to 1997. It's governed by what we call a Plenipotentiary Conference Resolution 176 on the human exposure to and the measurement of electromagnetic fields. And then in each sector of the radio, telecom, and development, we have resolutions that give the mandate to the membership to work on a topic. So what is the problem with EMF in the context of 5G? The electromagnetic frequency is really, may have healthy impacts. And what happened is that in 1998, there is the International Commission on Non-Ionizing Radiation Protection, or ICNIRP, which is based in Munich, Germany. It's an international body that has international experts, completely independent from the industry. They're not paid by any company. And those experts set some limits on the EMF, electromagnetic frequency, and the power density in terms of potential harm to the human body. Because our body is an antenna, and depending on the frequency, it's a very high frequency, it doesn't really impact us, it bounces. If it's lower frequency and it's high power, it might heat up the body, especially people at the time were worried about the eyes, for example, heating up if you have a lot of radiation, which could be very painful and could have health consequences. So ICNIRP set up limits in 1998 on the EMF. Then the World Health Organization, which is another UN agency dealing with the health, adopted those limits as a resolution of the WHO. And then the ITU, as the International Telecom Union, the ICT agency, developed standards on how to measure the EMF in the ICT ecosystem. And then the ICT ecosystem uses those EMF measurement standards to be the arbiter between the regulator, the operator that's deploying equipment, the regulator that has the well-being and the benefit of the society in hand, and now a lot of the consumer groups or the residents and so on that might have difficulties thinking that the antennas might have a negative health impact. So having scientifically based studies and limits is an important element because there is a big emotional side to this discussion. And if you go with the emotion, you could really inhibit the deployment of 4G and 5G in Europe and elsewhere around the world. So this picture was very important to explain yesterday to the parliament members in terms of preparing the code in Europe, because a number of countries in Europe, including Italy, today will not be able to deploy 5G in a cost-effective way. Poland, Belgium, Paris, not all of France, but Paris as a city, have some very, very strict and severe limits. So in the ITU, one of the study groups that we have, called Study Group 5, works on the environment, climate change, and the circular economy, and has one of the working parties working on electromagnetic compatibility, lightning protection, and electromagnetic effects. And this is the body that develops those standards for measurement and also the guidelines on how to do it. They have a question dedicated on the human exposure to electromagnetic fields from EMFs from ICTs. So what this study group develops is now we have about 10 recommendations. We call them, they're international standards, but in the ITU diplomatic language, we call it a recommendation because it's up to each member state to adopt it as a national law or a national standard. We have about 10 of those normative international standards, and we have what we call supplements, and the supplements are technical reports or non-normative text that guides the conversation that may explain a problem or a situation, as I will show in a moment in terms of the impact of EMF on 5G deployment in Europe. And then we have, in addition to the standards, there is an important element of raising awareness, because if the people, the citizens, fear that the EMF will kill them or kill their children, of course they're going to be adversarial to deployment of towers and microcells and so on. So it's important to really put down the true scientific issues on the table and try to avoid the emotional or deal with the emotional part. And that's where we have a website dedicated on it. We have applications on iOS and Apple, Google Play, where a lot of this information could be open and accessed in 6 languages of the UN. So now the intersection of EMF and 5G. We have a number of documents, what we call the supplements on 5G technology and human exposure to RF radio frequency EMF, the exposure limits to 4G and 5G. So what's new in 5G that requires a different look at electromagnetic frequency? We have new techniques of, first of all, we're using higher frequencies. So the WRC next year will allocate frequencies in the higher bands. We have higher throughput needs. We need to be addressing 1 gigabit and up to 10 gigabit per second per user. We have smart antennas. We have small cells. And we have the Internet of Things and the massive connectivity. So all of these new elements in a 5G have certain implications from an EMF perspective. For instance, if we do beamforming, maybe the density and the EMF power will increase momentarily on that area where the beams are formed. And depending on how the regulator is measuring the EMF limits, if they go on the peak, they may limit that beamforming application. If they go on the average, they may allow it. So having a harmonious standard on measuring the EMF impact is an important element. About a month ago, we had a delegation from Poland, which is one of the European countries that will be severely limited by the current ICNIRP limits, along with delegations from India, from Ericsson, Nokia, China Telecom, Huawei, Uganda, Cisco, GSMA, Vodafone, Telstra, Korea, and Belgium, that came to address this document from Poland, the contribution, which has the title, The Impact of Radio Frequency EMF Exposure Limits Stricter Than the ICNIRP or the IEEE Guidelines on 4G and 5G Mobile Networks. And here there are 3 levers that are severely impacted. First of all, operators might have frequency available to be deployed. They need to deploy more bands to deploy 5G. They might have that frequency available, but if they deploy it, they will hit the limit. The second one is with new techniques of beamforming, smart antennas, and so on. If they deploy these new techniques, they will hit the limit again. And the third aspect is that with the small cells and dense urban planning, you need to deploy more and more cells. And as you put more cells, your cumulative power will exceed the limit. And so that's the third problem. And so this document explains those issues and then makes a call for the regulation in Europe and elsewhere around the world to be updated in line with the current technology. So just to give you pictorially the real impact, on the top you have the WHO limits that are based on ICNIRP, and these were established in 1998. And here the volt per meter is about 100 is the public exposure limit, the red line, and the black line is the occupational exposure limit. So if you work in the telecom field, you have a slightly higher limit than the average person, because you're around equipment all the time. And then the Polish limit, if you see the blue arrow, you see the scale is about 10 or 12, whereas the WHO limit is about 100. So it's almost an order of magnitude stricter than what the WHO says is okay. And this dates back to the Russian time, when Poland was part of the Soviet Union. The limits were very strict. And Poland has not updated its regulations since then. It's not the only European countries. Italy, as I mentioned, a few others have strict limits, maybe not as severe as Poland, but these limits would have a significant impact on the deployment of 4G and 5G. So in this study group 5, and I used this because I was talking about it yesterday, and I wanted to give you a concrete example of how technology, politics, and business comes along into an international standard, like this one on the EMF limits. The technology is around the exposure limits and the measurement techniques. The politics is because the politicians, if they go and change the laws without any backing, they'll have the citizen groups going after them. And the business, the operators cannot deploy this technology if there is no guidelines that would allow this deployment. So this is a very good example I thought that I would give you in terms of some of the work that the ITU does and why it's important to have all the stakeholders around the table. The member states, which are the ministries and the regulators, the companies building the equipment, the operators deploying the network, and the university and academic research institutes, the scientists that don't have necessarily a biased view on the issue to bring fresh ideas and fresh considerations to the table. So study group 5 is open for your involvement if this is a topic of interest. Our next meeting is in September in Geneva. And I promise the Pope will not be in Geneva in September. So now let's move on to some of the newer topics. So EMF is a traditional, very good example of traditional work that we have been doing. Let me quickly now move on to the latest technologies, the artificial intelligence. In 2017, the ITU held the first global summit on artificial intelligence. We were extremely pleasantly surprised with the turn, the participation, the caliber of people that came, researchers from Berkeley, Stanford, X-Prize, IBM, really all of the top thought leaders on artificial intelligence and machine learning were in Geneva for 3 days talking about how we can use artificial intelligence for good in terms of addressing the 17 Sustainable Development Goals in the UN Sustainable Development Goals. Based on the success, we had a second summit just a few weeks ago on the second take of the AI for Good Summit. But this time, we had a lot more participation, almost 800 people, 60 countries, 37% women. In the first summit, it was not very gender balanced. In the second one, we really worked on it actively. We had 120 speakers, 30 countries, 34% women speakers, 48% from the industry, 30% from academia, and 16% from the UN bodies, and a 7% government, so ministries, regulators, and so on. And this time we focused on 4 tracks. The first one was the AI satellite imagery for crisis management. CERN, which is the European Research Center for Nuclear Research, is in Geneva, and they have a lot of data that comes from the satellite. They store a lot of the satellite imagery. About 30 people or so in CERN working on this. And so we looked at with Professor Stuart Russell from Berkeley, the BEAR, Berkeley AI Research Lab, on how the satellite imagery could be used in crisis management, in preventing theft, in many humanitarian applications. There was another track looking at the AI-powered good health and well-being. And as a result of this track, we now have a focus group that will be created probably next week in Slovenia to look at the AI for health. So how can we standardize some data sets, formats? How can we standardize interfaces to the data sets? And how can we have an architectural agreement that would allow the use of AI algorithms on data sets for health, for prediction, for proposing cures? Because today there is a huge shortage of medical doctors around the world. The WHO estimates a shortage of at least 15,000 generalists. And that's, for some countries, you have 2 choices. You know, you have no treatment, or you have, if you have an application that might give you some indication, it would be useful. The third track was trust in AI. There is a lot of, as we talked, maybe tampering with the data is an issue, biasing the algorithm an issue. Can I really trust the AI algorithm if it's being used for the autonomous car? I think we were talking about the Google car last night, and the image that was misrecognized of the woman with the bike as opposed to woman on top of the bike. If you have a problem like that, how can you trust who's got the liability? And then AI citizen services in a smart city context. So when we talk about smart cities, we're talking about deploying a lot of data collection, and then to really be smart, we need to act on the data. And so we need to have machine learning and AI to enable that smart city in real time. one of the key elements in the artificial intelligence is the data. So without data sets, we cannot talk about machine learning or artificial intelligence, and we need those data sets. And they need to be open, and they need to be available for research community. And so the ITU opened the research, an AI repository, and at the AI Summit made a call to all the data owners, if they wish to anonymously or put some data in an anonymous form in our repository, and we're starting to get data sets from various players. For example, in the 5G machine learning, we've been calling for operators to share with us some data without necessarily giving us the exact topology or the location of the network, because that will allow Fraunhofer and other research institutes to develop algorithms for predicting the position of the user, for managing the network resources, for addressing new slices of the 5G network that need to be deployed. And again, there you ask, where is the standard element? The standard is in the data. If we have data in various different formats, it's going to be impossible to do machine learning or treat the algorithms. If we don't have standard interfaces to tap into the network, we won't be able to use it. And if we don't have an agreed architecture, it's not possible. So that's what the focus group on machine learning is working on those three elements: data, format, interfaces, and architecture. I mentioned this at the beginning in terms of mapping the digital world on the physical world. In the context of smart cities, it's essential, and there are various ways of doing AI. It could be centralized or distributed. It could be generalized or tailored. So these are the various forks of the AI research, if you will. For IoT and smart cities, maybe I need to accelerate a bit. In the context of IoT and smart cities, we have a focus group, study group working on the Internet of Things standards. All of the 1M2M, for example, standards have been adopted by ITU, by this study group, to make them international. We also have some original work on the identification for IoT, the security of IoT. But more importantly, perhaps, that has an impact on citizens is the smart city key performance indicators, where we developed a standard on how to measure a city in terms of smartness. And the group that worked on this came up with 130 data sets or data points that need to be collected. And based on those data sets, then we developed a report to the city so that it can work on improving its smartness. Some of the work in study group 20 are around drones for IoT, IoT requirements for edge computing, AI and IoT, smart manufacturing, and industrial Internet of Things. This is probably one of the key elements. I see, for example, Intel very active in this field, because Intel is in many manufacturing shops, automotive or otherwise, and there is a lot of data, perhaps more data in those networks than you have on the public network. And so having the industrial internet, the machine learning on those networks is perhaps as important as the social media and the people data. IoT for developing countries, ITS, privacy and trust and interoperability. For smart cities, we're looking at open data in smart cities, the use case requirements and architecture for smart cities, the smart city in rural communities, smart parking, disaster notification, smart tourism. This was a contribution from Spain that is really trying to transform its economy based on smart cities, smart tourism, using the service and digital economy as a new platform for economic growth. And they're very active in this study group. One of the smart city platforms that were adopted was a national standard in Spain that they brought to ITU, and then it was adopted as an international standard. In terms of data management and processing, we have a focus group working on that. So the Smart City KPIs is an initiative that has 16 UN agencies working on it, including the ITU, to take the KPIs, the key performance indicators, and deploy them, try them in the cities. The first city that went with this was Dubai. It was 2015. And through the experience with the pilot project with Dubai, they learned a lot, and the ITU community learned a lot, because some of the standards were developed by a community, not necessarily of city experts. That we had some mayors and we have some ICT experts, but having domain experts in any of the IoT conversations is critical. So having city practitioners practice this KPI was important. And so when they tried to collect this data, first of all, they found that some of the data is not currently collected. Some of it is in different formats. And some is not really useful in the current way they're collecting it. So based on this experience, there were, and the other piece is that there was no regulation for data sharing, which is critical. And so this really enabled the change of laws within Dubai and UAE to have a framework for data sharing. After Dubai, very quickly, we had Singapore that tried the KPIs, and we issued 2 reports now for Dubai and Singapore. And since then, we now have about 50 cities that are in the process. For example, in Tunisia, just a month ago, we audited Kairouan and Bizerte, Smart Bizerte and Smart Kairouan. And it was really an eye-opening exercise for the mayor, for the governor, for the minister, to go through the 130 data sets and realize, for example, that there is a lot of water being wasted. So they need to find out, where is the leak? Is it being stolen? Is it there is leaking pipes, and water is a very scarce resource, just as a random example. But there are many other examples. If you don't measure something, you cannot really manage it. And that's why in the smart city, we started with some very basic data in the 3 dimensions: education, ICT, and the environment sustainability. These are the standards that were published for the KPIs on smart cities. This is a typical report after we do the audit. In terms of the percentage of the KPIs that are verified, we bring an independent auditor from Canada, and he goes to all the cities that are being piloted. So we have a consistent audit of the data that's collected, and then we provide a report back to the city so that they can put a master plan on how they are going to develop the city in a smart fashion. But an important element here that is to keep in mind, not all the cities are built the same in terms of physical location, history and culture, citizen behavior, and many other reasons. So when we treat smart cities, is not to make them all the same. What's important to one city may not be as important to another. So big data is an important element when we talk about IoT, machine learning, and AI. The middle there is the new fuel of the economy, of the digital economy. It's the data. So the volume of the data, the variety of the data, the velocity, variability, and veracity. This is back to the tampering with the data in doubt. So it's a very important, critical, central point in our conversation now about standards or new technologies. We go from data, filtered, visualized, and storytelling, and now it's about insight and action is where a lot of the algorithms in AI and machine learning are being used. Quickly on smart intelligent transportation systems, once a year there is the International Geneva Car Show in March. We leverage this, having the world of automotive industry converge on Geneva to have a one-day workshop on the future network car, where we bring the ICT sector and the automotive sector together. And this has been around for many years and has been proven to be an effective tool now as convergence is happening between ICT and automotive. And from it, this conversation came a number of standards. The vehicle gateway in the car. So we have a standard on the gateway in the car. The ITS cybersecurity, the Hyundai standard that I mentioned earlier. The quality of service of speech and audio in the vehicle, ITS and Internet of Things in smart cities, and the numbering. When we talk about a connected car, it's using an E164 number, a telephone number. That's one of the ITU standards. We issue a country code to Turkey, for example. Then Turkey issues the next series of numbers to the operators. But what happens when a car is roaming across all of Europe? They need a number that operates. They cannot be constantly roaming, or could be Latin America or elsewhere. So when a device, an IoT device, needs to be connected across multiple jurisdictions, multiple geographies, countries, they get a code directly from us, from my department in ITU. We give them an E164 code, and then they are listed in our database, so all the operators would know who they are. They know how to do the charging and accounting, and then they can operate in multiple countries. Now we get almost one application a week or every 2 weeks for M2M applications. Could be automotive, it could be Wi-Fi devices that are offered so that you buy it once, but then as you go globally, you still have Wi-Fi with different operators. So this is opening up a whole new set of applications, but it's using another critical resource managed by the ITU, which is the E164 numbers. Let's see. I'll skip over some of these slides in the interest of time. Another element, very quickly, is the financial inclusion. Today, there is 1.7 billion adults that are without a bank account of any kind. They're not banked. Out of those 1.7 billion, there is 1.3 or so that have a mobile device. So it makes them a very good target to be enabled with some sort of financial service. And on that, we have been working with the Gates Foundation for a number of years and the World Bank to use mobile devices and ICT to provide for financial inclusion. Here, there is a lot of new techniques for securing the connectivity. We're looking at SS7, for example, vulnerabilities that are created because of the conversions between voice over IP and traditional telephony to fill those holes or address those security gaps, because the USSD channel used for sending and receiving money could be tampered with, and we need to secure it. So that's one of the standards element that comes back to ITU from this conversation. Let me skip over these. I think I can leave them with you. These are some of the standards in the health, multimedia, numbering, accounting, and charging. The quality of service and quality of experience we touched upon briefly. And then in terms of the study, so all of these standards come from 11 study groups that we have today. Those are the areas I'm responsible for in the ITU, which are from operational aspects, economic and policy, environment and climate change, broadband and cable TV, signaling requirements, performance, QoS and QoE in Study Group 12, Study Group 13 working on IMT 2020 from a fixed network, transport access and home networks, multimedia security, and IoT and smart cities. These are open, the study groups are only open to the members, including academia members, but we have also the open platforms like the focus groups, and these are short-lived in nature, but they don't publish standards, they publish reports. So now we have 4 active focus groups on machine learning for 5G, the application of distributed ledger technology or blockchain, digital currency, including digital fiat currency, and data processing and management supporting IoT and smart cities. We also work on bridging standards gap because traditionally Europe and North America have been very active players in the ITU because they were developing the technology and setting the standard. Now there is a shift to the east with China, Japan, Korea, having a lot of the innovation come from there. But we also see a growth from countries in the developing world taking an active role in at least defining the requirement, saying, you know, in Africa, we need these certain requirements to operate the network. And so we have a program to really enable delegates, representative of these countries, to be able to write an effective contribution, present it, defend it, and be part of the international negotiation that takes place. I will skip the rest on BSG, but it's an important element of our program. I want to get to the third point, which is ITU and academia. So universities and academia are really critical, and this is our Secretary General, Hulin Zhao from China, who is elected by the 193 member states. So he has the same status as a head of state or government, and has been in ITU for many years. The first time I met him was 2001, when he was the director of the Telecom Standards Bureau, where I currently work. And he is personally very committed to the academia and to the small and medium enterprises. He really wants to open the door for ITU. In fact, the ITU changed its model in 2010 to open membership to academia during his time. What's the benefit for universities to join ITU? Network with the 193 member states, the 700 private sector, and the other 140 academic and research institutes. Contribute to the standard. As I mentioned, Fraunhofer Institute makes very essential contributions, video coding, machine learning as examples. BUPT from China leads our work on network management. So we have some very active universities in the ITU. They can become editors, rapporteurs, so taking on leadership positions. It could be used for knowledge and learning. By interacting with the rest of the international community, you know what are the real new problems, because the standard is usually a year and a half to 3 years before the market. So if you're developing a research plan and you want to validate if this is really interesting for the industry, you come to ITU and you see what Huawei and Orange and all the others are contributing, and you have an idea of where the industry is heading. The international promotion and the image of the university as being part of the ITU. Access to all the documents. So the pre-standard work is not public. It's only available to the members. But once the standard is published, it's available on the website. So if you want to have the insight into what's cooking now, you need to be a member. Partnership, experts. We rely on a lot of experts when we go into developing countries to do training. We usually go and tap onto our academic experts to do the training. Of course, it's paid missions that they would do. Part of the debates on policy and regulation around the world, publication and statistics. A lot of data that is normally sold is available at a significant discount to academia. But perhaps most importantly is engagement of the youth. So the engineer that you are training today in the university, if they have an exposure on the standards setting environment in the ITU, they will be a much more effective engineer once they are out in the marketplace, because they will have a much more global perspective on the industry they will be working in. Let's look at so the current community is quite diverse from how many countries? I think 50 plus countries. And the topics, I think we covered those. We covered the study groups. And the sectors of the ITU. There is also the ITU Academy. This is for training developing country people and delegates. And input could come from academia in terms of the training and the courses. They are both online and in person. The academy.itu.int is our website for it. And finally, I want to get to two last messages. One is the conference we called Kaleidoscope. Kaleidoscope will have its next edition in Argentina from 26 to 28 November in Santa Fe. And it's focused on machine learning for a 5G future. The call for papers, I think the deadline is next week. So in case you happen to have a paper on this topic you wish to submit, please contact me very quickly. I'll have my contact info at the end. And the best papers, we have an agreement with the IEEE ComSoc that the best papers are published in the IEEE Communication Magazine. 1 minute, and then I'll be done. So this is more detail on the Kaleidoscope and the call for papers, the email address, the link, and the prizes. For the best 3 papers is about 6,000 will be shared among the 3 best papers. And then finally, the ITU Journal. The ITU used to publish a journal a long time ago. We stopped for a while, but again, our Secretary General Hu Lenzhao recently, a couple of years ago, wanted to put it back in place and offer academia an international platform for scientifically reviewed papers. We had the first issue that was the impact of artificial intelligence on communication networks and services. This is published already, and the link is there. And now we have the second issue on data for good. So again, the call for paper is open. The deadline is the 30th of July. And we would very much welcome your contribution to this journal. And finally, if you wish to join ITU as an academic institute, if your university is in a developing country, the membership is very low. It's about 2,000 Swiss francs. If it's in a developed country, it's about 4,000 francs. In comparison with the sector, the company membership fee, it's orders of magnitude less, about 18 times less. Because we don't really need the money from the university, we need the intellectual property, the research, the ideas that will generate new standards and These are some testimonials from some of the leading universities, Georgia Tech, that we have a partnership with on IoT, the Nanjing University of Post and Telecom in China, the EPFL in Switzerland, in Lausanne, the George Mason University in the US, the Tsinghua University in China, and a university in Colombia. So it's quite diverse set of universities that are active in ITU. And I hope that through the 3 points I shared with you today, the industry ecosystem, what the ITU is working on, and the venues for collaboration with academia will be useful, and hope to be collaborating with you in the future. Thank you.
Thank you, Bilel, for your presentations that show clearly that standardization is also essential from a research perspective, as our research is somehow industry-oriented, and to see one day our results to be deployed in the real world, we have to be aware about our standardization process and so on. So I took the opportunity to ask the question. So to be concretely a member from, for a research lab or a research institute, to be a member or to be part of the standardization process, are there any conditions? No?
No conditions.
No.
It's a very simple process. We have a one-page application online that you fill, which is here on the Join Us slide. I think it is. Anyway, I thought we had the link here, but and it's once you submit the application, what we do is based on where the university location headquarter is, we go and ask the member state.
Okay.
So if, for example, SUPCOM in Tunisia wanted to join many years ago, we went to the Ministry of ICT in Tunisia and said, SUPCOM would like to be a member. Do you have any objections? No objections, fine. We send the bill to SUPCOM. They pay their 2,000 Swiss francs, and they're a member.
Okay.
It's a very easy process. It could take, if everyone responds within a day, it could be 1 day.
Okay, thank you.
SUPCOM is a member.
member.
Esprit is a member. And,
So the only condition to fill a form and to pay
2,000 francs in a developing country.
Okay.
And so developed countries, like if you're in Europe or North America, you pay 4,000.
Okay.
If you're in a developing country, we have the list.
Okay.
In a developing country, it's 2,000. So to make it easier, because currency exchange, economic purchasing power is different.
Okay. So adjust
Per year.
Sure,
And it gives you access to the 3 sectors, the telecom standards sector, the radio communication sector, and the development sector.
Just a jump to the second question. I know, so for example, IETF is very active also in the standardization process. What are the relation between ITU activity study group? You show different study group. There's also some working group on the same topic somehow in IETF. What are the relation between this organization?
So the IETF is one of our qualified SDOs that we reference in our standards. So we can make reference to any RFC. When it comes to TCP/IP, we don't have any new work in the ITU on TCP/IP because that's the domain of standardization for IETF. So we simply make references to the RFCs. Beyond the TCP/IP core set of standards, ITU develops standards on media coding, fiber optics, and so on. So there is in a way, a collaborative relationship where we reuse TCP/IP standards from IETF, and the rest of the ecosystem is completed by work in the ITU.
It is more a collaboration instead of competition, or
I mean, the industry it would not be a healthy thing for competition for the industry, because at the end, vendors need to build a product to a standard. So if you have confusing standards, the industry would be confused. That's why, for example, we adopted all of the 1M2M specification release 2 are all now adopted as ITUT recommendation, because we needed a middle layer. 1M2M developed the middle layer software between the devices and the applications. And when it came to the study group 20, the international community that was not active in 1M2M actually liked the work. They had some comments on improvements that 1M2M is now taking into account. But grosso modo, like 90% has been adopted without any change.
Thank you. Okay.
Changes in Those limitations that you talked about, those are very important.
Yes.
And like in Poland, for instance,
Yeah.
would they be, is it easy to change those limitations? Is it more political?
It's an excellent question. The reason yesterday this briefing to the parliament was initiated by Poland, the member of parliament from Poland initiated this briefing. So he invited ITU, ETNO, the European Telecom Operators, Network Operators Group, GSMA, and the Boston Consulting Group that did a study on the impact of EMF for Poland. The idea of inviting these external experts to the discussion is to start the dialogue at the European Union level and try to have a European common standard of limits that then will be adopted by the member states. So if you cannot fight the battle locally within your own country, it might be easier to have the conversation at the European level, and then once all of Europe agrees, then the member state would have to implement.
Okay, Moshe anticipated the part of my question. So, but how long do you think this process can take?
I am optimistic that it will be by the time the IMT 2020 standard will be published. So in the next 2 years, we will have harmonization
Very
of
quick
limits.
to be adopted at the European
At the
level. Then single countries
Then
must
countries
adopt
will adopt their national laws.
Okay, because this is really important and really serious, because we are talking about 5G, we will do that, we will do this, but without this agreement, it is impossible to do anything.
Absolutely.
And one of the key concepts that we are advertising is that vertical sectors is one of the main objects of 5G, but if you think to logistic, fleet management, it's impossible. If I am, I don't know, Coca-Cola, it's impossible to make fleet management with 5G if in Poland I can't. Okay. And the last part of the question, in this frame, while the rules will be harmonized at European, do you think that the satellite can have an increased role? Because the power flux density from satellite is low on ground. Maybe it respects these limits, of course, in the limit of performance the satellite can provide.
The satellite may play some role in filling the gap of connectivity, but if we look at the promise of 5G in terms of the low latency, the 1 millisecond latency, it's impossible to do it with satellite. Even with today's network, even today's 4G network cannot do it. 5G needs to get the fiber to the microstation and get the edge computing as close as possible to allow for these sub-millisecond or millisecond reactivity. So certain applications will not be possible with satellite. If we talk about the massive connectivity, again, the IoT connectivity, you need microcells close to as a gateway to the IoT devices. How can you cost effectively deploy satellite terminals to fill that gap? So it's not evident that it could be a solution. But in terms of the growth of bandwidth, having 1 to 10 gigabit per second to user requires a lot of frequency, requires a lot of cells and proximity between the end user device and the cell. And without lifting the limits, the ICNIRP limits, the supplement I showed that is listed in our slides shows the study that was done by the Boston Consulting Group, and then it was brought to ITU through Poland, that it's impossible to deploy 4G or 5G in Poland, Belgium, Italy, Paris, and Hungary. These are at least 5 European countries and cities that cannot benefit from 4 and 5G today. So it's a very serious, and it has a huge economic and social impact, and that's why it's taken up by the members of parliaments, the ministers. But the other aspect you need to remember is the emotional part of the citizen groups that say, I don't want an antenna in my neighborhood because it's going to kill my kids. So how do you deal with that? You need to have more scientific evidence, more informational videos, explanation, maybe town hall meetings to explain that. And of course, the politicians that are elected, they're not going to change the law if the citizen groups are going to turn against them. And that's why it's a delicate one. It's technical, it's political, and it has a huge business and social impact.
So I would like to thank you for your nice presentation, which is very complete. I used to be a member in IETF working group, especially in money working group, and I have proposed so many drafts around OLSR protocol. That at that time there were so many industrial lobbies who impact the final decisions in this institution, and they would like to know how things are going on in ITU.
Yes, very good question. My first interaction with standards was actually in the IETF. So I used to work for Nortel in Canada, and I was working on designing and implementing software and hardware on a passport switch, a frame relay and ATM switch. And so my manager at the time said, you know, we're hearing a lot of noise in the IETF about tax switching. Can you go to the next IETF meeting and come back and tell us what's happening? So I went and I came back alarmed, saying, oh my God, Cisco is bringing tax switching to IETF, and they're making this new standard with it, and we already have a lot of label switching, so we need to bring our technology to the IETF. And that was the starting of my career in standards. So I know how the IETF works quite well. I have a number of RFCs in my name. 2340 was the first one. So if you look at the numbers now and then, and it was about virtual network switching. It was Nortel's label switching product at the time. So the IETF is a completely different animal from the ITU, in the way that, one, the decision-making is through rough consensus and running code. The rough consensus is determined by the chair of the working group and could be overridden by the area director. So it's very personal. The person who's got the leadership of the group has a lot of power, and it's very hard to debate or influence that power. And so when I was with Nortel, our game plan was, having seen the scene, I told my management that if you are serious about IP networking and MPLS, we need to invest heavily in the IETF, and we need to hire all of the working chairs of technologies that are important to us, or we need to become the chairs. So that's what we did. And then I evolved in my career in Nortel to make that happen. So the decision-making, and then you have the running code. So perhaps this is a nice aspect of it, is that you're not talking in the abstract about paper standards. You actually have a product that is running the code. And when we realized that, we asked for a demo of label distribution protocol. So the first industry demo of label distribution protocol for MPLS was between Cisco and Nortel in 1998. And that brought the balance of the conversation, because we had running code, we became credible as a player in the IETF. But in the IETF context, one, if you don't speak English well, you're out of the game. There is a microphone with a queue of many people, 400 or 500 people in the room, a chairman who may or may not be biased, but in most cases he's paid by somebody, so he has an agenda. And then a draft is presented. Sometimes they tell you 10 minutes, and 2 minutes later he says your time is up. And then you have a queue of questions. They're in English, and if you're not a native English speaker and you cannot argue in English, forget it. You don't come to IETF. So from that perspective, IETF is very different to the ITU. The ITU is having all of the stakeholders around the table, the member states, the vendors, the operators, the academia. You don't shout in the meeting, you ask for the floor, you're given the floor by the chair, and the chairman, the consensus process is built from the working group, we call it the question, to the working party, to the study group plenary. So the decision-making process is very transparent. You cannot really bully the group into a decision. If there is no consensus, you're not going to have a standard. So it's a different animal. It's a different, and the scope is limited to TCP/IP in terms of the wide deployment of technologies, and doesn't necessarily always have the regulatory aspects in mind. So it's useful because it developed a lot of important technology. The internet runs on the networking layer runs on IETF standards. The optical layer runs on ITU standards. So 95% of the internet traffic runs on an ITU standard today. So if you keep the full picture in mind and you're rational about it, you can understand that if you're only in the IETF and the company paying you has only routers, you have a different perspective of the world.
You mentioned consensus a lot.
Yes.
In ITU.
Yes.
Very important.
Yes.
What happens if there is no consensus or people have a political agenda?
We had a vote in 2011 exactly because of MPLS TP. It was a commercial fight between Cisco and Juniper on one hand. They are packet companies, and they had a solution for the MPLS TP that is based on the packet layer. And on the other hand, in main part, Huawei, ZTE, and Alcatel that had a solution based on fiber optics. So it's two perspectives. One is coming from layer 2 down, trying to use it as a circuit, and the other has a circuit trying to packetize it. At the end, it's more or less the same solution, but coming from different customer base, equipment based, and patent base. So it's a commercial fight. It's not IETF versus ITU, but for 3 years, it turned into a battle of IETF versus ITU. This was from 2008 to 2011. So when I joined ITU in 2010, that was the biggest problem I had to deal with, this MPLS TP. We had meetings in Geneva with half the room of IETF experts, people, and the rest of the room is ITU people, and they just go at it for hours and days and weeks at a time, and we don't have any resolution. So after 3 years, Italy took the flag and said, Chairman, in the rules of the ITU, a member state can ask for a vote. So Italy took the flag and said, Chairman, Italia Telecom was also wearing the hat of Italy. He asked for a vote. He said, I'd like to move to close the debate and move to a vote on this topic of MPLS-TP recommendation. It was seconded by Russia, and we had a vote in the meeting.
Voting is not ITU.
It's not the usual style, but it's there. We have it in our rules. We can use it. And after 3 years, Italy was fed up because Italia Telecom was deploying a lot of the Huawei equipment, and they needed a standard because they cannot deploy it based on no standard. And they know it works. They know it's perfectly well, and it's just a commercial fight. They asked for the vote. They won the vote, and then we moved on. So knowing that you can vote is an important encouragement towards consensus.
Okay. My question is about VANETs. So VANETs allow communication between vehicle to vehicle and vehicle to infrastructure. And since many years, we are using the SRC, dedicated short-range communication. So my question is, when we will have, we need the standard also, so because many researchers talk about other capacity of communication, and we need to equip the vehicle with this capacity. So when I do my training in Berkeley, they talk that about legislation
Yeah.
To put the SRC in cars, but doesn't come. So it's like now since many
Excellent
years.
question. Our last Future Network Car Day in Geneva in March, most of the debate was on this topic because there is a division in the industry. Some companies and countries want to use DSRC, and the others want to use LTE. Okay? And I think, at least as a neutral player, I don't have any commitment to one or another. It looks like the LTE camp is winning the battle. There is a huge automotive alliance of Audi, Volkswagen, and other car manufacturers with Ericsson and Nokia and other ICT, networking, telecom manufacturers, having an alliance to develop an LTE solution for vehicle communication, looking at how 5G is evolving, how the frequencies are being made enabled. I think that's where the industry is heading. But bear in mind that some other countries, like Austria, for example, is using an IEEE standard. So you might have some niche markets for a while, but I think long term it will probably be LTE-based Exactly. It's a homogeneous system.
Thank you. We have to close the session because we have, I think, almost 1 hour
Okay.
delay. So thank you again
pleasure.
for your very instructive presentation, Bilal. So maybe it's now.
So thank you, Dr. Bilel, for your informative talk.